Okay, slight ramp in difficulty. Let's inverse Laplace transform s plus 3 over s squared plus 4s plus 13. Okay. So you look at this thing.
S plus 2 squared plus 9.
Oh. Okay. So if you're a little clever and you're looking down the table a little ways, you'll notice that a ways down this table, there are e to the lambda t cosine and sine of omega t. Okay. And the lambda just shifts stuff around, right? It just evaluates your Laplace transform at like s plus or minus that lambda. So here you might look at this and be like, okay, s squared plus 4s is like part of s plus 2 squared, right? So let me get that part out first. So you go, okay, so this is the inverse Laplace transform of s plus 3 over s plus 2 squared plus 9. Oh, and that's too cool not to do the arrow here. That's a complete this square, right? Okay, so I completed the square. And then if you look in the thing, right, you're looking for s minus lambda on the top or an omega on the top. So you're kind of looking at this and you're going,
See an omega on the top.
s plus 2 looks like your s minus lambda, right?
Mm-hmm.
This guy kind of looks like your omega's 3.
Mm-hmm.
Since 9 is 3 squared.
Mm-hmm.
Okay, so I'm really kind of thinking lambda's negative 2, right? So you see an s plus 2 on the top? Or do you see a 3?
Yeah.
Plus 2 plus 1.
Yeah, so you need to rewrite the top. You guys see that? A little bit screwy.
Well, it's
This is going to be the funnest step ever.
Yeah, okay.
3 is 2 plus 1. Right? So you now have the inverse Laplace transform of s plus 2 over s plus 2 squared plus 3 squared plus 1 over s plus 2 squared plus 3 squared.
And then separate across the plus side.
Good. Now use linearity. So you get the inverse Laplace transform of s plus 2 over s plus 2 squared plus 3 squared. Okay, so I'm looking at that, I'm thinking cosine times an e. And then I got a plus the inverse Laplace transform of 1 over s plus 2 squared plus 3 squared. I'm kind of thinking...
And so you could
1/3 the right side.
put a 3 in and do a 1/3. Yeah.
Yeah, I'm looking at this and I'm thinking, hey, that looks a lot like a sine. Except it needs an omega on top. Omega has to be 3 because this 3 down here. So I better put a 3 in here. But you can't just willy-nilly slap a friggin' 3 in there, man.
1/3 out front.
You got to put a 1/3 out front. You guys with me? And then you hit that thing with the table, right? Just like smack the table against this thing. So you hit it with a table, and you get e to the minus 2t times cosine of
3t.
3t plus
1/3 sine
1/3
1/3 e to the negative 2t.
e to the negative 2t again, right? That's from the plus 2 in there. And then sine of 3t. You guys with me?
Mm-hmm. Check done.
Check done. So it's not exactly partial fractions, right? You guys see that?
That one wasn't.
Like this one's not, and even if it, you know, even if I had another factor in here, I'm not going to shoot for quite breaking it into linear pieces, right? Sometimes I'm going to shoot for breaking it into these kind of funny pieces because these funny pieces fit in my table. You guys see that? So you got to kind of know where you're headed a little bit. It's not just straight up partial fraction. You guys good with this? Like it would be a major dorkness to break this into s over this thing plus 3 over this thing, right? You need that s plus 2 and the one with the number. Like you want those two pieces to be separate. Good with this?